In this video, let's talk about LDM and STM, which are the instructions for loading multiple and storing multiple values. In our previous video, we discussed about how we move data between a single register and a single memory address. Let's start with LDM instruction. LDM instruction is used to load multiple registers from a consecutive memory locations. This instruction is highly efficient for handling operations where multiple registers need to be loaded from memory, such as storing a register state from a stack or loading a block of data. Here you have the syntax for the LDM instruction. Here the condition and exclamatory sign operator are really optional. You don't require them. Even if you are using a exclamatory sign operator, this indicates that the base register, that is Rn, should be updated after the operation. In the register list, you will put the values or the number of registers that are required, where you are going to move the values from the memory locations. There are major 4 addressing modes in both LDM instruction and STM instruction. Those modes are increment after, increment before, and decrement after and decrement before. As you can see, this whole mimic means load multiple increment after. This is similar with the other for load mimics and other for store multiple mimics. Now let's start with the store multiple instruction. The store multiple instruction in ARM assembly is used to store the contents of the multiple registers into consecutive memory locations. This instruction is useful for saving the state of registers to the stack or any other contiguous memory block. Now you will be thinking, what is the use of these two instructions? For saving the state of registers into stack, especially when before entering a function. For example, when entering a function, you may want to save the current state of the registers so they can be restored upon return, and load multiple can be used to restore those registers. Now let's understand this more at CPU later. Now let's discuss load multiple in CPU later. Let's take the base register R0. As I discussed, there were 4 addressing modes: increment after, increment before, decrement after, and decrement before. If you by default use LDM instruction without addressing or specifying the address modes like IA, the default addressing mode will be IA. That won't matter if you specify IA or you simply write the mimic LDM. Let's take the base register R0. For the registers in which the values from the memory addresses will be moved, let's use the registers R1, R2 and R3. For this showcase how this really works, the LDM instruction loads the value address of R0. Here, if you check in the registers tab, you will see the R0 contains the memory address, which is all zeros. If you go to the memory section and if you check the address where all values are 0, you will find this. And the R1 will be the taking the value of R0 address, and R2 will be taking the value from R0 plus 4. As you can see, at plus 4 we are having the value where all the bits are A's, and the R3 will be taking a value of R0 plus 8. This is the incrementation of all 4 bytes. If you are having a R4, that will be incremented 4 again, that will be R0 plus 12. Now let's change the values in the memory section. That will make it easier to observe the process of LDM. Let's first make this decimal sign, and making the values, let's put them random. 3, 34, and 5, and 0. As you can see, now according to the LDM instruction, R1 will be containing the value of 0, R2 with the value 3, and R3 with the value 5. Let's compile and run. After this step into, as you can see, the memory here has been changed, as it should be 0 here as we changed, but whenever a process is started, by default addresses are changed, as we have already seen that before once. So at the address 00, where all bits are zeros, this value has been moved into R1, and as after the 4 bits we have the value 0, which is moved into R2. Similarly with the R3. Now let's look for the store instruction. As store instruction moves the values from registers to the memory, let's load some values into registers first. Before doing that, let's refresh the emulator. As we are going to use the registers R1, R2 and R3, let's move the values into R1, R2 and R3. As now R1 contains the value 3, R2 with the value 4 and R3 with the value 5. Now let's write an store multiple instruction. There is no necessity of writing the store multiple instruction in the capital case, but for my personal satisfaction, I am writing those in the capitals. Let's take the source register R0, where the address from R0 will be taken as the base address. Now what really happens here is the address of R0 now contains the zeros, all zeros, and the value from R1 will be moved at address of R0, and value from R2 will be moving at address of R0 plus 4, and R3 will move the value from R3 from to the address R0 plus 8. As you can see, this will now be containing the value 3, and this with 4, and this with 5. Now let's compile and run. As you can see, by default these are the values that has been given to these memory addresses on the start. And after you step into the instructions, after you move the values into a register, and now before stepping in to these store multiple instructions, these are the values at the given addresses. Now if you step into, this is how the values has been changed, and the value from R1 is at this address, which is the address of R0, and this is address of R0 plus 4, which is containing the value from R2, and this was the address of R0 plus 8, which is containing the value of R3. And this is all for this session.